Hello, everyone, and welcome to another mini sky tonight. So I had a viewer ask me to possibly discuss some of the different details of the different planets, to look at how they were formed and some of the different features of the planets because they're studying the planets over the next course of a few months in their class. So I thought, why not do a whole solar system tour? Look at all the different planets in our solar system, excluding Earth, because if you want to go explore Earth, go outside. Because as we're all stuck here in the pandemic, go out on a nature trail, go walk around your neighborhood, go enjoy nature as it is. So obviously we can't travel to these different planets to check them out. So allow me to show you what we have discovered about these unique different planets in our solar system throughout several different videos. So today I'm going to be talking about Mercury and the closest planet to the sun. So let's dive right into it. So basic information, Mercury has been observed for thousands of years. In fact, some of the first recorded observations, now people have been seeing it for thousands and thousands of years, but the first recordings of viewing Mercury was in the 14th century BCE in Assyria, in some of their old tablets. And Mercury has gone by different names by different cultures because people have seen the planet Mercury in the early evenings and early morning skies. It's gone by Hermes, which is the Greek equivalent, but today we could call it by its Roman equivalent because the Romans kind of took over the Greeks and they just basically renamed their gods. In Assyrian, it was known as Odu Idim Giu. I'm probably butchering that name. I don't know Assyrian very well, but bear with me, but it was referred to as the jumping planet because it looked like it jumped from the east to the west and back again. And it kind of makes sense, as you can see in this diagram. Mercury is closest to the sun, so it doesn't travel very far from the sun. So wherever the sun is, chances are you're going to see Mercury close by. So hence why you can't see Mercury and its companion planet Venus not too far from the sun. You only see them in the early morning or in the early evening skies at certain times of the year. And also because you can't see them at midnight because they have to be close to the sun given their orbit. So wherever the sun is and given their respective orbit, like you see in this diagram, that's where you'll either find Venus or Mercury. So hence why it was sometimes nicknamed the jumping planet. To other cultures, it was called Nabu. The Chinese called it the hour star because it was usually seen roughly at certain times of the year, an hour before or an hour after, either an hour after sunset or an hour before sunrise. So it was often called the hour star. The Japanese called it the water star because they named some of the different planets after certain elements. The Norse called it after their god Woden, and the Mayan called it the owl, which was supposed to be the messenger to the underworld. So many different cultures called it by different names, but many people have observed Mercury throughout the years. So what do we know about Mercury? Well, for Mercury to travel around in its orbit, it takes 88 days. And that makes sense because since it's the closest planet to the sun, it doesn't take it too long to be able to finish one orbit. So 1 year is 88 days. So for every 1 year on Earth, Mercury can go up to 3 to 4 years. So 1 day, however, on Mercury is different. It takes a long time for Mercury to experience from one sunrise to the next sunrise because it rotates incredibly slowly because it's slowly being tidally locked with the sun, slowly. 1 day on Mercury takes 176 Earth days. So it takes a long time for it to finally be able to rotate completely to where it faces the sun. So it takes 176 days. That's crazy. Just because of its weird rotation rate. And it's roughly, even though it's really, really close to the sun, it's still 36 million miles. So if you wanted to understand like what we mean by astronomical units and why we use such big rulers, I'll leave a link up here for you to be able to check out why we use different rulers in our measurements. So even though it looks like it's very, very close, it's still several million miles away. Now, Mercury is not the hottest planet in the solar system. In fact, I sometimes like to call it the fire and ice planet because on one side it's incredibly hot, but on the other side it's incredibly cold. Because Mercury doesn't have very much of an atmosphere. We have an amazing atmosphere that's able to retain enough heat to where we don't freeze at night, even though we're so far away from the sun. Because it's able to retain the heat that it gets during the day and evenly distributes it throughout the planet. Now, Mercury doesn't have this luxury. It doesn't have an atmosphere, or it does have a very thin atmosphere, and I'll get that in a few minutes, but it doesn't have enough of an atmosphere to retain heat. So therefore, on the daytime side, when it's facing the sun, it is over 800 degrees Fahrenheit. But on the nighttime side, it drops down to negative 290 degrees Fahrenheit. It is so cold that nothing can survive. Even if you were to like literally stick a fire right next to you, you still would freeze to death. It's that cold on Mercury. It's crazy. But however, one of the cool features about being so close to the sun is that the sun will look incredibly bigger, and you can start to see some of the features of the sun much more easily. It'll be 3 times bigger in the sky compared to how big it is here on Earth. And as I mentioned, it's been observed for thousands of years, and the reason being is because it's an incredibly bright star compared to some of the other stars in our sky. It has a magnitude of negative 2.5. So in astronomy, we use the term magnitudes being how relatively bright it is compared to different other stars. Our sun is a negative 26 magnitude. The lower number you are, the brighter you are. The higher number you are, the fainter you are. The limits that a human eye can see is a magnitude 5. So for it to be a negative 2.5 is pretty bright. So you get to see it in the early evening and the early mornings relatively easy. It looks like a very bright star. Not as bright as its sister planet Venus, but still bright. And of course, it doesn't have any moons. Mercury and Venus don't have moons, and I'll talk about Venus next week or next video. But it's often said that the terrestrial planets don't have moons, or even weren't supposed to have moons. That it just happened to be that Earth and Mars got moons by fluke. Mars got moons because it captured a couple of asteroids from the asteroid belt, and Earth's moon was actually created from the Earth itself, not a moon that naturally formed alongside with Earth like some of the gas giant planets. Our moon was basically a chunk of the Earth that got knocked off and then it went into orbit. So the fact that 2 of the 4 terrestrial planets, or the rocky planets, have moons is kind of unique and rare. All right, so let's take an up-close and personal look of this planet, Mercury. Given different satellites and things that have visited Mercury, we've noticed that Mercury was once volcanically active. We see different types of lava flows. We notice that it has areas that kind of look very similar to our moon, like dark areas that look like Maria. They look like there was areas that basically look like they pooled in some cases. And some of the areas look relatively young compared to other surface features. So it kind of looks like our moon, basically. And the largest crater on Mercury is the Caloris Basin, which is, as you can see on the image on the far right, it looks relatively young compared to the surrounding area, which has a bunch of different craters. Yes, there's a few craters on the inside, but those are relatively new compared to the area that's on the outside of it. It also has these unique different features that are called compression folds or scarps. And these basically are wrinkles on Mercury. So you kind of can see it in the image on the top left. It looks like these fine lines that go through Mercury. But these scarps are basically compression folds or wrinkles due to internal cooling. It's thought that over the course of several years, Mercury cooled down a bit. And since it cooled down, the crust on top of Mercury started to shrink down. Like when something cools off, it starts to compress a little bit. Also, Mercury has highlands, kind of like our moon. So many of these highlands are sometimes created either by volcanic activity and or they were created by crater impacts. So the surface of Mercury is very similar to our moon. It's just, it happens to be just a little bigger than our moon and closer to the sun. So for you that want to be able to feel like you weigh less, the place to go is Mercury, because the surface gravity on Mercury is 3.7 compared to Earth, which is 9.8. So you would basically weigh about 1/3 the weight on Mercury. If you want to make a trip out to Mercury, that'll help you boost up your ego a little bit, but honestly, just keep at it. If you can, try to lose some weight, try to stay healthy. I know it's incredibly hard, but keep at it. It is worth it. And as I mentioned, it does have a very thin atmosphere, and exceptionally thin. They say it has like 1% of the atmosphere that our Earth does. So it barely anything to breathe there. And many astronomers believe that this atmosphere is created by just thin layers of ice that is on the cool side. And as Mercury starts to slowly turn, that those materials, that gas that froze on the frozen side starts to heat up and creates a very thin atmosphere on the far edges during the daytime, nighttime side, but very thin. And so we have the beautiful view of Mercury, but that was not always the case. As you'll notice in the image on the top left, there's that one area that kind of looks blank. For a long time before the space probe Messenger went out to Mercury, this was the best image we could get of Mercury. And the reason being because, as mentioned, it takes 176 days for the space for Mercury to rotate. So that one little sliver was always just way too close to the sun for many other spacecraft to be able to image the surface of Mercury. So we always had this unknown sliver, but thanks to Messenger, it had this protective shield on its back, so it was able to quote unquote turn its back towards the sun and take some better images of it. So now we have this beautiful full view of Mercury. So yes, you can now do a Google Mercury and basically put yourself on the surface of Mercury should you desire. So as you can just see from this image, and it's false colors, so that way you can be able to see some of the different craters and details a little bit more easier than if it was an actual colored scale, because some of the craters don't pop out as much. So as you can see, it kind of looks very similar to our moon. And you can definitely see these white little trails. That's why I created this false colored image. These white little trails are basically trails from the craters, or sometimes known as ejecta lines. So as a big space rock smacks into the planet, it spews out material, and that material falls into these straight lines. Now, Mercury, since it doesn't have an atmosphere or any type of thing to kind of wash away some of those ejecta lines, they stay there permanently. All right, let's go deeper into the planet. Let's look at how it's structured. Mercury was thought to possibly be the core of another planet that could have been, because it has a large metallic core that is literally 85% of the planet. It has a core very similar in size to what cores of other terrestrial planets could be. So many astronomers believe that maybe Mercury, if it was put into orbit around the Earth, it would be just about the size of Earth, if not slightly bigger. But since it was so close to the sun, all the excess material got pulled into the sun. And the reason being why it has such a big metallic core is because there's a process when in planet formation known as sublimation. So think of it kind of like putting a bunch of junk into a bunch of water. The heavier stuff sinks to the bottom, the lighter stuff rises to the top. That's what goes on in the planet as well. So all the heavier elements, all your bunch of your irons and stuff like that, start to sink towards the center of the planet, Well, the lighter materials start to rise up to the top. That's what creates internal heating. It's the second densest planet to Earth, where Earth is roughly the densest planet. Dense meaning density just 3.8 grams per cubic centimeter compared to other different planets. But one of the weird things that astronomers were curious about and were blown away by is that it does have a magnetic field. Now, what creates a magnetic field in a planet is that you have a metallic core, not a solid core, a metallic core, a liquid metallic core, and that it rotates inside the planet. So in order to get a magnetic field, you have to basically have this liquid metal rotating fast enough to where it creates a magnetic field. Astronomers believed that it couldn't have existed because it doesn't rotate fast enough to get what is known as the dynamo effect, or basically the core, the planet itself doesn't rotate fast enough to where the core inside doesn't rotate. But that's not the case, and astronomers are interested to find out more about this. But they also noticed that not having the North Pole and South Pole directly north and south, they also noticed that it's kind of offset a little bit compared to its north and south. So astronomers are thinking it's possibly due to the core being non-uniform, or that there's some different unique structure going on inside Mercury. And the way we discovered that it had a magnetic field is we noticed some ion trails above the surface of Mercury. As the sun released solar wind, it would be caught in Mercury's magnetic field, and we would see these kind of weird ion trails as it goes past Mercury. So it hinted to us, hey, there's a magnetic field on Mercury. So who got all this information? How did we get all this information? And what's next? The first visit to the planet Mercury was Mariner 10, to where it studied its magnetic field. It was the first one to take close to a full image of Mercury, hence that little unknown strip. It lasted for about a year, but it ran out of power, as well as it couldn't get too close to the sun or else it would start burning up. In fact, it's a fun little fact that when it finally ran out of fuel, they just let it drift off. It didn't land on Mercury. So it's still orbiting the sun. It's one of the few spacecraft that is still in orbit, quote unquote. It's just adrift. I found that just really interesting and weird. But in 2004, we sent another spacecraft to Mercury, as I mentioned, Messenger. Now, if you love anagrams, this is the spacecraft for you, because they must have fun making the names of these different spacecraft, because Messenger literally stands for Mercury Surface Space Environment Geochemistry and Ranging. They must have had a heyday putting all these different letters together. It kind of reminds me of the movie Sneakers, where they basically just take a bunch of bananagram tiles and put different words together just because they can. They must have fun with it. But the whole point of Messenger was to look at the density and the geology, as well as to take a full map of Mercury and to study the very thin atmosphere I was mentioning. But coming up, it was launched in 2018, Bepi Colombo, I think is how it's pronounced. It's basically a Japanese and European Space Agency organization collab, where they sent this spacecraft in 2018 and it's hoping to arrive in 2025. So that's something to look forward to, hopefully in the next couple of years, of finding out more about our planets. It's going to look at the interior as well as do some more deep focus on some of the different surface features, like some of the Caloris Basin and some of the different scarps there, like what really created them, and could the surface features be related to what's going on inside Mercury. Hopefully we can possibly find out how Mercury does have a weak magnetic field, especially since they're going to study the magnetic field for the first time using a magnetometer. Now, this was something that wasn't put on previous spacecraft, so now we're going to have a magnetometer to basically understand how the magnetic field of Mercury looks. So this is kind of a bit of an up-close and personal view of the closest planet to the sun. So where can you see it? Where can you take a look and check out this planet for yourself from the comfort of your backyard? Well, if you head out towards the early evening right about now, so around late January, if you look towards the south-southwest, just shortly after sunset, you'll see kind of like this little faint star close to the horizon. That is the planet Mercury. And if you have a pair of binoculars or a small telescope, you can check out this really cool planet. So that's the first planet of our planet tour. I'm hoping to be able to do some of the more planets either starting next week and or as the weeks go on. If there's a particular topic you would love for me to cover over, leave it down in the comments below. If there's a question you would love for me to answer, leave it down in the comments as well. Also, I know we're starting to get close to Valentine's Day, and some of you are looking for some fun ideas. If I may suggest Earth to Sky Calculus, it's a student group that basically sends weather balloons up into space, and they take a payload of different items up into space as well. And those items have officially been in space. So if you're looking for like a nice piece of jewelry for your wife, or you're looking for a baseball for your baseball fans out there, or you can even request certain objects to be sent up into space, they can do that as well. I'll leave a link in the description below if you'd like to check them out. So until next time, stay safe, stay healthy, and as always, never stop learning.